Solving linear inequalities is almost like solving linear equations, except there's one big caveat you have to keep in mind, and that is this. You must beware whenever you're solving linear inequalities, if you multiply or divide both sides of an inequality by a negative number, you must flip the sign. It's not optional, it's absolutely necessary. If you'd like an explanation for why this is true, please feel free to ask me and I'd be happy to explain to you. But we're going to just take it for granted right now. So if you want to solve this linear inequality, what would you need to do to both sides? Well, x is being multiplied by -3, so we'd undo the multiplication by -3 by dividing both sides by -3. However, if you multiply or divide both sides by a negative number, you need to flip the sign. So before I even write anything down, I'm going to write this as less than, because I need to divide by a negative number, specifically -3. And when you divide the left-hand side by -3, you get just back x. And what do you get when you divide 15 by -3? Well, that's precisely x is less than -5. So when you divide both sides by a negative number, you need to flip the sign. This inequality is equivalent to this inequality, and this one has x isolated. Let's take a look at this one. When you have x over -3 is greater than 15, how would you solve for x? Well, you'd want to multiply both sides by -3 since x is being divided by -3. But again, if you multiply or divide both sides by a negative number, you must flip the sign. So already, I'm going to write this like this, as the less than sign instead. So if you multiply this left-hand side by -3, you'd be left with just x. And if you multiply the right-hand side by -3, you'd get -45. This inequality is equivalent to the original one, but it has x isolated. So you have to be conscious of this fact anytime you're solving linear inequalities. Now, one more question here before we get to a couple of practice examples where we want to solve for x and then we'll also graph the solution set. Would you flip the sign when solving 3x is greater than -15? Well, you got to think about what you do. You want to isolate x, so what's happening to x? X is being multiplied by 3. So how do you undo multiplication by 3? Well, you would divide by 3. But 3 is a positive number, so when you divide by 3, you will not flip the sign. You should not flip the sign. Who cares if this is negative over here? It's all about what's happening to the variable x. It's being multiplied by a positive 3, so I am not concerned with this in this scenario. So if I divide this side by 3, I get just x, and if I divide this side by 3, I get -5. So in this case, x is greater than -5, not x is less than -5. So be careful with that. Let's get some more practice. Here we've got two inequalities that we want to solve, and then we also want to graph their solution sets. And notice, for example, when you look at this, we're going to need to use the distributive property. So all the stuff you learned about solving linear equations also applies to solving linear inequalities. But let's start with this left-hand one. So we want to isolate w. First, we need to subtract 1 from both sides. And when you do that, you get -9 on the left is greater than or equal to. Remember, when you subtract 1 from 1, that gives you 0. But then 0 minus w is the opposite of w, not w. As many of you would say, we get -w. But now, how do we get w fully isolated? Remember, the opposite of w is w times -1. So this is like multiplying by a -1 out here. The way to undo that would be to divide both sides by a -1. And notice I just said divide both sides by a -1. That means I need to flip this sign. So I'm going to do that first. I've now got the less than or equal to sign instead of the greater than or equal to sign. And when you divide this side by -1, you're left with just w. And when you divide -9 by -1, you're left with just 9. So this is the solution to this linear inequality. Let's now graph this solution set. Of course, 9 is a boundary point, so we're going to mark down 9. And 9, of course, is to the right of 0 because it's positive. And since 9 is less than or equal to w, that means 9 itself is a solution because you have the equality there. So we're going to put a closed circle there, i.e. a filled in dot. And then where are the rest of the solutions? Are they to the left or to the right? And remember, if you are the type of person that reads this as less than means go to the left, that is not true unless the variable is on the left-hand side. So if you need to, you don't have to rewrite this, but if you need to be able to graph it, this is the same thing as w is greater than or equal to 9. Again, this is not necessary to write, but if it's going to be necessary for you to get this part right, then you probably should do that. So W is greater than or equal to 9 means we want the numbers that are larger than or equal to 9. Those numbers are out here to the right. So they go out this way and they go on forever, so I'm going to put an arrowhead there. We solved that one. Let's take a look at this one here. Our first move, just like as if this was an equation, would be to do the distributing. So 3 times that difference is 6x minus 3 is less than 5 times that difference is 5x minus 5. Just like with equations, if you've got variables on both sides, you want to get rid of one of them. So I would subtract 5x from both sides. If I subtract 5x from the left, that would give me 1x minus 3. And if I subtract 5x from the right, I'd get negative 5. And now the final move here would be to add 3 to both sides. If I add 3 to both sides, that would give me x on the left and negative 2 on the right. Notice there was no division at all at any point during this, and especially not by a negative number. So notice the sign stayed the same throughout. So we have x is less than negative 2. So let's draw the solution set. Well, negative 2 is a boundary point. Negative 2, of course, is to the left of 0. Mark that point. And then negative 2 is not less than itself. So this is going to be an open circle here. Now, where relative to that point are the solutions? Well, we want all the numbers less than negative 2. They are to the left of it. So they're this direction, and they go on forever. So we have an arrowhead there. And again, make sure you realize these are two totally different problems. These two number lines are not actually running into each other. We now have seen how to solve linear inequalities and to graph their solution sets.